Welcome to qnawire.
In this question, we have a bat emitting an ultrasonic wave of 4.5 times 10 to the 4 hertz and flying at a speed of 6 meters per second between two parallel walls. And we are to find the two frequencies heard by the bat and the beat frequency between those two frequencies, assuming that the speed of sound is 330 meters per second. Now, this is a bit of a tricky question because for each of the walls, we're going to have two Doppler shifts. So because the bat is moving towards the wall and emitting a sound, the emitted sound wave is going to be Doppler shifted. And then also the wave that reflects off of the wall and goes back towards the bat will also be Doppler shifted. So we need to do two Doppler shifts for each wall. So let's start off by calculating the first Doppler shift. And in this, we're going to be considering that the bat is the source of the sound and that the wall is actually the observer. So we're trying to figure out what frequency the wave is actually hitting the wall with. Okay. So we're going to label, maybe let's label this wall number 1 and wall number 2 just for clarity. So wall number 1 we're moving towards, wall number 2 we're moving away. So let's do the Doppler shift for wall number 1. And let's go through some of the givens here. I'm going to use the notation that's used in the book. So U0 is the speed of the observer. Since the wall is the observer, in this case, we're going to use 0 meters per second. US is the speed of the source, and it's positive when it's moving towards the observer. So we're going to use 6 meters per second. And then we also have the emitted frequency that was given in the question. And then the regular V is the speed of sound. That's going to be 330 meters per second. And our goal here is going to be to find the observed frequency. So let's go ahead and calculate or just jot down the formula for that from the book. And then we can sub everything in. Okay, so the V is 330 plus 0, 330 minus 6, positive 6. And then we're going to multiply that by the emitted frequency. Okay, so let's see. So we've got 330 divided by 324 and multiplying that by the emitted frequency. We get something very similar. So it's about 4.6 using sig figs, 4.6 times 10 to the power of 4 hertz. That is the frequency that the wall is actually receiving here. Now, let's do the second wall. The second wall is a bit different. It's going to receive a slightly lower frequency because the bat is moving away from it. So for the givens, this is for wall number 2. For the givens, they're actually going to be exactly the same, except our speed of the source is going to be negative because it's considered negative when the source is moving away from the observer. Okay, it's moving away from the wall, so we have to use a negative here. So we're going to use that exact same formula, but this time we're going to use a negative for US. So it's going to be plus 6 because minus 6 gives us a plus. Okay, so this time we're doing 330 divided by 336. And then we're going to multiply that by our frequency. And using sig figs, that does give us 4.4 times 10 to the 4 hertz. Okay, so we've done the first Doppler shift. We have figured out the frequency that each of the walls will experience, or each of the walls will receive. Now we're going to do Doppler shift number 2. And in this, we're considering the wall is the emitter now because the wave is being reflected off of the wall back towards the bat. So the wall is the source. And the bat is the observer because we're trying to figure out what two frequencies the bat hears overall. Okay, so again, let's start with wall number 1. And let's think about what the givens are now. So again, we want to kind of switch the source and the observer, so we have to be a bit careful here. So this time, the speed of the source is going to be 0 because the wall isn't moving. And for the speed of the observer, the bat is again moving towards the wall, so we consider that as positive 6 meters per second. For the emitted frequency, we're going to use what we found in the first part, so 4.6 times 10 to the power 4. And of course, we still have the speed of sound, 330 meters per second. I'm not going to write that again. So here we go. We're going to use our same formula. Oh, let's see, U0, V minus US. Okay, so we'll plug everything in. So that's going to be 6. And then just a V on the bottom, so 330. And plug in the frequency as well. So this time we have 330 divided by 336 divided by 330. And again, multiplying by that frequency. So 4.7 times 10 to the 4 hertz is our frequency, one of the frequencies that the bat emits. So that's one of our final answers. Okay, now we have to do wall number 2. And what are the givens for that? They are the same, except we now have a speed of the observer is negative 6 meters per second because it's moving away from that back wall. And the emitted frequency is what we found in part A, or, what I'm calling part A. Okay, so again, we'll just plug it into the formula here. So that's going to be 330 minus 6 over 330 times 4.4 times 10 to the 4 hertz. Okay, here we go. So it's going to be 324 divided by 330. And again, multiply by the frequency. So that's going to give us about 4.3 hertz times 10 to the 4. And that's another one of our final answers. So the bat hears those two frequencies that we just calculated, and they were Doppler shifted twice. And then the only other thing we need to calculate is the beat frequency. And that's just going to be the absolute value of the difference between those two frequencies that the bat hears. Okay, so to get the beat frequency between two frequencies, you just have to subtract them. So that's going to give us 0.4 times 10 to the 4 hertz, or we can write that as 4 times 10 to the 3 hertz. Okay, so that is our beat frequency and our final answer.